finally, let's take a look at some 5 megapixel lens comparisons. And I like to use this one here because we have 2 different vendors both calling their lenses 5 megapixel lenses. And again, clearly on the left you could see that the lens is a better lens, even though both are saying they're 5 megapixel, which leads me to the megapixel myth. Lots of lens manufacturers now call their lenses megapixel or 5 megapixel or 10 megapixel lenses. Hogwash, I say. As you saw before, lenses are rated in line pair per millimeter, not pixels. So let me disprove this megapixel myth. Here's a table of sensors. These are standard sensors you'd find in standard cameras. And going down, we increase the number of pixels. However, I've also picked these sensors specifically because the sensor size is increasing and so is the pixel size. On the rightmost column is the MTF limit. And here you can see that the 11 megapixel Kodak lens, which is a very large sensor, has very large pixels, has the lowest MTF. So the 11 megapixel sensor needs a lower quality lens than the 1.4 megapixel sensor. Now I chose these lenses specifically to make this point, but do not automatically equate the number of pixels to the marketing description of a lens. Notwithstanding what I just said in the previous slide, once one manufacturer started calling their lens a 5 megapixel lens, all of the manufacturers did the same. However, there's no standard for this rating, so there are huge differences in the performance of A's 5 megapixel lens versus manufacturer B's 5 megapixel lens. The biggest rule of thumb to go by with lenses is normally you will get what you pay for. A $500 lens will be better than a $100 lens. However, on the smaller scale, this always won't be true. For instance, a $150 lens might not be performing better than a $125 lens. Also, newer designed lenses perform better than older designed lenses at roughly the same price point. So if you're looking at a $150 lens and one was designed in 1995 and the other was designed in 2011, typically the one designed most recently is going to perform a lot better. So as I said earlier, First Vision is an independent distributor of products. We don't have any dog in this fight for lenses. Our goal is to solve your problem given your time and budget constraints using whichever of the products are best suited and available. We carry all the major brands of lens: Computar, Edmund, Fujinon, Kowa, our own OEM brand of lenses, Pentax, Schneider, and Tamron lenses. Each of these brands has multiple lines: megapixel, 5 megapixel, 10 megapixel, etc. Now, manufacturers don't give out data for all the manufacturers. Some manufacturers will tell you line pair per millimeter, but don't give you a contrast curve with it. Or they won't tell you if the measurement was done on axis or off axis. Very few manufacturers give full data. Schneider Optics is one of the few. So how could you determine which is the best lens? You probably can't, but we tested them. You can test them yourselves as well if you can get the proper equipment. Schneider Optics lent us their projector that has a resolution slide that projects through the lens that you're testing, and it looks like the picture on the right. The white rectangles that you see represent the various sensor sizes: 1/3 inch, 1/2 inch, 2/3 inch, etc. Inside of the white rectangles are little resolution charts. So you see these all over here and here and here, and these represent all of them for one sensor size. And what they look like when you take a close-up picture is they have line pair per millimeter charts. So what we did is we took various lenses from the manufacturers, put it on the projector, then took a 10 megapixel Nikon camera, put it in macro mode so we can get real close and got an image of each lens at various points on the rectangle. And what you do is you get a set of test results that look like this. And you could see, for instance, that set 4 does not look as good as this set down here. So what are the results? Well, unless you're looking at these on a large high-resolution monitor, it's very hard to see the subtleties between lenses, though of course some do stand out. You can easily see differences between a $100 lens and a $1,000 lens. However, each picture that we took is 10 megabytes. It's a 10 megapixel camera. For each lens, we took about 5 pictures or more. And we tested at least 15 different lenses. So the data file is going to be at least 750 megabytes. We can't email to clients 750 megabytes, and we can't put it up on our website because 100 people downloading roughly a gigabyte, our hosting provider is going to think this is very strange. We also can't compress the data because then you won't be able to see the differences. If we compress it to reduce the data dramatically, it's going to be a very lossy compression, and that's going to take out all the data that you're trying to see, whether it's clear or not. So here's what we can tell you. If you're using a 1/2 inch or smaller sensor and looking directly on axis with a 2/3 or larger inch lens, and you don't need to measure anything, just image, pretty much any lens we carry will do the work. By measuring, I mean if you're looking at someone's face and you just want a picture of their face, that's okay. If now you tell me you want to measure the distance or the size of the pupil of the eye or something like that, it's a whole different story. Otherwise, there are too many variables, many of which are application dependent, and there are many variations that are very subtle. One lens brand, for instance, might be great on axis, but not off axis. Or it might be better with chromatic aberration, etc., etc. So it's very application dependent. What we can tell you is, call us to tell us what your application is, what camera you're thinking about using, what your budget is, what you're potentially willing to compromise on, and we can discuss which lenses would best fit your needs. Thank you very much for listening. I hope this has helped out. You can contact me directly at info@firstvision.com. Again, thank you very much.